Hi students, this is Mr. Yao. Today we're going to talk about 9.2 where we will learn about inverse trig functions and cofunctions. So first, let's have a look at what it means by inverse trig function. In the previous lesson, we have learned all 6 trig ratios, but we have only been identifying them and just using them. And we have done things like sine 9 degrees. You know the angle already, and you're just trying to find the sine value for it. And inverse trig function is the exact opposite of that. Just like when you did inverse operation to solve an equation, here inverse function is used to find the measure of the angle. And that we read it as arc. So here they are. Here are the 3 main inverse trig functions. Sine theta equals x, and then theta equals arc sine x. And sometimes we actually, instead of writing the -1, we just write them using the word arc. So arc sine x, arc cosine x, and arc tangent x. And here's what it actually means. So for example, in the previous lesson, we had sine 9 degrees equals 0.156. Okay, if that's the case. In this lesson, we're just saying we don't even know what degree is. We don't know it's actually 9 degrees. We just know sine of something is actually 0.156. We're trying to find that angle, which means this angle is going to become sine to the negative first power, or arc sine of 0.156. We're trying to find what angle makes the sine 0.156. So that's what it means. And here's another reason why we use arc to present an angle. Because if you recall, in a circle, we have an arc. Let's say our arc is right here. The measure of this arc is the same as the central angle. So since an angle, that's why I use the word arc to represent. Now it's time to practice on our calculator how to actually do these calculations and find the exact value of them. So let's have a look. You look carefully on top of the sine, cosine, tangent, we clearly have something else. We have these -1s, and that is where we actually have the inverse functions. So for example, the first one, we're going to press secant, then sine. That's going to find us what is arc sine 0.5. Round to the nearest whole number, so 30 degrees. And since it's an angle, we need the degree symbol. Next, number 2, the inverse of tangent of 1. So that's going to be 45 degrees. And number 3, which is cosine, arc cosine 0.86. That's going to give us 31 degrees. We're going to do the same thing with the last one. So secant, and then we're going to press sine. .75, which is 49 degrees. We still have tangent. Secant, tangent 6, which is 81 degrees. Number 6 looks slightly different, but it doesn't change anything. So that one is just sine c equals that value. And we can represent the angle C using the inverse function. So C is the inverse of 0.2250. I can use our calculator, secant cosine 0.2250, which is going to give us C equals, why did I use cosine? It should actually be sine. So the question is the inverse of sine, so let's use sine 0.2250. That is going to be 13 degrees. Number 7 is actually very similar, so we're going to do the same thing. Cosine b, so b is arc cosine of 0.1045. 2 secant, and then cosine 0.1045. Enter. That is going to give us 84. Number 8. Same idea. Tangent, so inverse tangent of 1.2700. It's going to give us 52 degrees. Moving on. This time we're going to do things slightly different. We already know the triangle, but we're trying to find the angle of theta. All three sides are given, which means we can actually use any ratio that we want. So let's try it out. Sine, and that is theta, opposite, so 3/5. Which means if we want to find the angle theta, we're going to do theta equals the inverse sine or arcsine of 3/5. Actually type in your calculator, that should give you, the question says round to the nearest 10th place, that should give you 36.9 degrees. That's number 9. Next, number 10. Oh, and another thing to emphasize on number 9, you can also choose to use cosine or tangent. So if you use cosine, and cosine theta is 4/5, you're just going to do cosine 1/4. Or if you're doing tangent, tangent in this case is going to be 3/4, so theta is tangent of 3/4. And after you solve them, you should all get 36.9 degrees, no matter which ratio you use. Number 10, hypotenuse is not given. You can totally find it using the Pythagorean theorem, but you don't have to, because we still know the opposite and the adjacent. Some good habits you can have is as soon as you see a right triangle and you see an angle, start labeling each side as opposite, adjacent, and hypotenuse, which will help you in identifying trig ratios. So in this case, it's opposite and adjacent. Clearly, that's tangent. Tangent theta is 7/11, and that theta is going to be, not sine, is tangent. It's going to be the inverse tangent of 7/11. If you type in your calculator, that should actually give you 32.5 degrees. Next. This time we don't know that, we just know this is adjacent and that's hypotenuse. So CAH, we can use cosine. Cosine theta is 14.5/16. Theta is going to be the inverse cosine of 14.5/16, which is going to give you 25 degrees. Next, number 12. We can, 3 sides are given, we can use any of them, so I'm just going to use cosine this time. So cosine theta, the adjacent, which is 3/5. Theta is the inverse cosine of 3/5. That's going to give us 53.1 degrees. Now actually look carefully. For example 9 and example 12, they're actually very similar. Because the triangles are both 3, 4, and 5. I just have labeled different angle. This is the angle that's next to 4, and this is the angle that's next to 3. And you can see the 53.1 and the 36.9, they make up 90 degrees. This is where we are going to talk about cofunctions. Before we actually do cofunctions, let's recap on that triangle again. So sine theta, theta 1, in this case is going to be 4/5, because for theta 1, this is the opposite, that's the adjacent, 4/5. And cosine theta 1 is going to be 3/5. But I'll actually change things up a little bit. Now I'm looking at theta 2, and this is the opposite, that's the new adjacent. So in this case, our sine theta 2 is going to be 3/5, and our cosine is going to be 4/5. So if you look carefully, these two are actually the same, and these two are actually the same, which means something. That's where we talk about cofunction. Sine and cosine, you see the word co. Secant and cosecant, you see the word co. Tangent and cotangent, you see the word co. And they have a very special relationship. And here's why before you even get into the relationship. That co actually is representing complementary. And this is complementary secant and complementary tangent. If you think about it, complementary actually means two angles add up to 90 degrees, which means if the sine and cosine have the same value, they should be adding up to 90 degrees. So let's have a look. Theta 1 is the same as 90 minus is the same as cosine of 90 minus theta 1, which in this case is theta 2. Cosine theta 1 is actually the same as sine theta 2. So it's always the opposite angle, and if you look for a different ratio, they can actually form 90 degrees for us. So now let's have a look and practice a bit more. If sine 30 degrees is 1/2, we want cosine something to be 1/2. We just need the angle that is 90 minus 30, which is 60, the complementary. And for the next one, same idea, 90 minus 0, that's going to give us 90 degrees. And next, same value, so 90 minus 23, that is 67 degrees. And last one is 90 minus 75, so it's 15 degrees. And example 14, we're just going to write the whole thing by ourselves. Since we know sine 50 is 0.766, we're going to have the same value for cosine, 0.766, and the angle needs to be complementary, so 40 degrees. Next is going to be 0.848, and the sine is going to be complementary for 32 degrees, which is 58 degrees. Now that is everything for 9.2. Thank you.